Okay, I'm going to take you through problem solving some of the more difficult types of algebra problems where it would be a pretty lengthy process just using a table to solve it. I'm going to use the thinking blocks application as part of Math Playground. So to load that, just hit start. I'm going to put the problem in similar to the problem number 7 on the sheet. So for me to get that, I'm just going to go and up here to problem 7. And of course I've changed the numbers around a little bit. But this problem says an equal number of boys and girls attended the school fair. When 12 boys and 66 girls left, there were 3 times as many boys as girls. How many girls attended the school fair at first? Of course, when you do this, you're going to wind up making a no chart. And I'll just do mine off to the side over here. We know that there were an equal number of boys and girls at the start. So I'm just going to say equal number B and G at start. However, 12 boys left, 66 girls left, so I'm going to say 12B left, 66G left. When that all happened, there were 3 times as many boys as girls. Times as many B as G. The question is how many girls attended it at first. Well, if there's an equal number of boys and girls at start, well, then that means how many girls were there at the start, that will be the same number as the number of boys. The next step would be to make a table. Making a table for this problem is kind of tricky. In order to do that, you would have to think about, first you have the boys, and there's no really solid way to make a table here, but the boys and the girls start off with the same number, and then I'm going to say B minus 12 for one of the columns, and then girls minus 66. And when you do that, you should find out that the boys will be 3 times as many as the girls. So those will be your labels, and I have no good way to really draw the table here. But the trick to solving this problem is to think about it with the end in mind. What I mean by that is start with what you know. You know at the end, if we say this is your girls, I'll put a little label up here. Spinning ball of doom. Let's see how long that lasts. Okay, we have our label. Let's say this is girls. Well, then boys at the end will be 3 times as many. So I'm going to put 1, 2, and 3, and I'll throw up another label, and let's say that is boys. Now, we know for that to have happened, whatever the total was for boys, they must have lost 12. So we don't know what that total was to start with, but whatever it was, they lost 12. The girls, on the other hand, whatever their total was, they lost 66. All right. Well, here's where the conceptual part of this problem is. You need to think about how many more did the girls lose. And I'm leading you into your next step by saying that. Well, if the boys lost 12 people and they started the same, and the girls lost 66, then that means that the girls lost 54 more people than the boys. Watch what I'm going to do here and see if you can kind of figure out why I'm doing this. So the girls lost 12, the same as the boys. However, they lost 54 more. So not only did they lose the same amount as the boys, which was 12, they lost 54 more. When you look at this model, you can see that 54 is making up the difference between the boys and the girls. So these two parts, in other words, are equal to 54. Otherwise, they would be the same, because represented by the same. So there's nothing represented by the 12 that they both lost. However, the 54 more that the girls lost will make up these two parts. So you need to think, well then, these two parts would be equal to 54. So what is each part then? Take that 54 divided by 2. You can think 25 plus 25 is 50. Well, each one of these is going to be 27. And maybe I shouldn't have written minus 12. Probably should have written lost 12. Lost 12. And then this part is the 54 that they lost. So, but on the other hand, the boys didn't lose 54. So they kept those two 27s. So each one of these parts equals 27. So now we go back to the original question. How